A very good morning to all. Welcome to Unacademy, my dear friends. How are you? How are you, my dear friends? Please confirm the audio and video portion. Okay. Good morning, Ayush, Harshit. Good morning. All okay? Okay. चलिए स्टार्ट करते हैं. सॉरी फॉर द डिले. आज फिर से थोड़ा सा प्रॉब्लम आ गया था टेक्निकली. माय सॉफ्टवेयर सेटिंग वाज आउट. सो फ्रेंड्स, आई एम योर फ्रेंड ऐश्वर्य. पढ़ाता हूँ आपको गेट ईएससी के लिए एंड आई हैव डन माय एमटेक फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया मिलिया इस्लामिया. 4 times I have qualified GATE with my best AIR 226 and I do have 6+ years of teaching experience and 2 years of industrial experience. Okay, and these are the subjects, my dear friends, which I basically take on Unacademy official YouTube channel, Unacademy special classes, as well as Unacademy Plus, Theory of Structure, RCC, and Geotechnical Engineering. And nowadays, I am also bringing a special question series on strength of material, and soon you will be seeing me in soon you are going to see me in taking crash course on strength of material. Okay, and this is a code #10 which you can apply, my dear friends, before buying any Unacademy Plus subscription in order to avail 10% off. And all these are the benefits of Unacademy Plus subscription, like you will be having daily live classes, crash courses, rank improvement batches, or doubt clearing sessions, weekly tests. And apart from this, the courses are running on both the languages, English as well as Hindi, and you will be having a very good and learning interface so that you can interact and learn with educator. Okay, is it clear to all, my dear friend? And it is the schedule for the month of September. Hydrology, structures, FM, environment, geotechnical new portion, full geotechnical engineering, steel structure, RCC, and engineering mechanics. Okay, and here you can see this we are running till 25th of the September, and geotechnical will be completed by 25th, and from 26th Abhishek sir is going to start structural analysis. Okay, is it clear to all, my dear friend? And yes, due to our structure, Chetan sir's mechanics is going to postpone by a few days. Okay, चलिए start करते हैं. Welcome to lecture number 53. Okay, although the topic for today's topic is influence line diagram, but I think we should actually attempt one more problem on circular truss. Okay, so announcement is that Wednesday, Thursday, and Friday. Wednesday, Thursday, and Friday. So in all 3 days, we will be having SOM test. SOM test. Okay, on special class, and platform for this would be, sorry, special class only, and timing for this would be 4:30 p.m. to 6 p.m. 4:30 से 6, है ना. तो स्पेशल क्लास में टेस्ट हुआ करेगा, है ना. ठीक है. आयुष केबल नहीं हो पाएगा. केबल व्हाट आई विल डू आयुष, केबल आई विल say to Chetan sir or Abhishek sir to cover in their portion. Okay, क्योंकि you can solve the problems of cable by simply using the it is very much similar to trusses. Okay, so by simply considering the summation of fx is equal to 0, summation of fy is equal to 0, and by using the Lami's theorem, okay, so you will be easily able to solve the cable. Okay, don't worry for that. In fact, in the last test which I have taken on structures, there also I have given a problem on cable. Okay, so you can practice cable, and I will be in next test. I am also going to incorporate cable. So I can simply make you understand cable by the mean of several examples only. Okay, जब भी मैं नेक्स्ट टेस्ट लूंगा उसमें केबल से 1-2 क्वेश्चन डालूंगा और देखेंगे किस तरीके से हम उसको टैकल कर सकते हैं। ठीक है, केबल कोई ऐसी चीज नहीं है कि उसको अलग से करवाया जाए, है ना। इट इज अ बेसिक मैकेनिक्स, लेमिस थ्योरम। ठीक है, ओके, चलिए। सो क्विक रिवीजन, we were studying yesterday arches, and we have seen how to calculate bending moment, reaction, radial shear, and normal thrust. These things we have seen yesterday. Okay, so today we will be discussing basically ILD, influence line diagram. But before that, I will be completing yesterday's problem only. Okay, this is ILD and a problem on circular arch. Okay, so yesterday I have taught you that how to calculate the radius. Okay, how to calculate the y distance in the circular arch, and we have already calculated, I think, bending moment in the circular arch. But today what we are going to do, we have to calculate the other segment of yesterday's portion. क्या था कल का क्वेश्चन? Okay, at E we have to calculate radial shear. Okay, at E we have to calculate radial shear and normal thrust. Okay, okay. So okay, आयुष जी ने निकाल लिया है। लेट्स सी कितना था लोड ये, एकदम बताते जाना। 100 था ना? So this was E, and E was located at a distance of 4 meter. Okay, and this total was I guess 20, and this was 5. Okay, so here we have to calculate this angle theta. So some center was somewhere here. Suppose this is my center, and it is going to be like this. Okay, suppose it is a circle, and this angle you must know. This angle you must know. Okay, is it clear? So we have already made the free body diagram of AE. Let's say this is my AE. AE. Okay, so what was the reaction? Tell me आयुष, एक बार reaction बता दीजिए आयुष, क्या थे? So reaction was 30 or 70. and it was 60. So here also it was 60. Prabhudev SG is asking, sir, what is the meaning of Janith badge? Prabhudev ji, Janith badge means that badge which will take you to a great heights. Okay, and importantly, we have to give name of any batch. Okay, so what we did, we classify our batches into two parts. One is Janith, another is Drona. In Drone batch, we are covering the subjects in Hindi, and in Janith batch, we are covering the subjects in English. Okay, so this is a thing here, and we have to think for this anti and this SR. Okay, anti and SR, and let's say this angle is theta. Okay, chaliye. Why I am considering only 30 and 70? See, summation of fx0, summation of fy0. No doubt bending moment will also be there, but today I am not interested in bending moment. I am only interested in radial shear and normal thrust. Okay, okay. Thanks, Prabhudev. Thanks. Okay, so this angle is theta, and now I have to calculate anti and SR. And anti and SR, how can I calculate? Let me resolve these forces. Okay, so let me resolve these forces, and it is going to be equal to how much? Minus 60 cos theta plus anti minus 70 sin theta is equal to 0. So anti is coming out to be 60 cos theta plus 70 sin theta. Okay, now let me come over SR. So if I am doing summation of Fy is equal to 0, then it is minus 70 cos theta plus 60 sin theta. क्या हो रहा है? Plus SR is equal to 0. So SR is coming out to be 70 cos theta minus 60 sin theta. Okay, so now the thing is to calculate the value of cos theta and sin theta. So it is coming out to be, this is theta, and let's say this is center O. And yesterday we have seen how much is this, and today we are seeing. So I think this theta and this theta are going to be same. I hope you know this thing. And if you don't know, then see here. This is theta. This is 90. This is 90 minus theta. And this complete angle is 90. So 90 minus 90 minus theta is again theta. So that's why this angle and this angle is same. Is it clear to all? Okay. So this is radius, and this height is how much? 10. This is 4, and it is equal to 6. So sine theta is simply 6 by 12.5. Okay. And what about cos theta? Cos theta is this over 12.5, है ना? तो बता दीजिए कितना आ रहा है. एंगल निकालने की जरूरत ही नहीं है वैसे तो. ओके. व्हाट इज cos theta? It is I think 10 point कितना आ रहा था कल. 10.96. 10.96. Okay. So substitute this value. This is coming out to be how much? So NT is coming out to be 60 into 10.96 upon 12.5 plus 70 into 12.5. Okay. So check the answer, Ayush. Okay. So is it coming out to be the same? Okay. So what is the answer here? दोबारा लिख दो एक बार. 86.23. पक्का. And what is this? And it is 32.6. Okay. So that's all. Okay. Good. So this is a way to calculate normal thrust and radial shear in circular arch. And suppose, my dear friend, if a same problem has been given to you in parabolic arch, then I already told you how to calculate theta. Theta is what? It is tan theta is equal to dy by dx. So d by dx of what is y here? 4hx L minus x upon L square. So if you are going to differentiate it, it is going to be 4h by x L square L minus 2x. So this is tan theta. Is it okay? Is it okay? Okay. चलिए. Okay. Now see, as I promised you, I will also tell you that how to tackle two hinges arch. Although I am not going to solve any problem on two hinges arches, but yes, two hinges arches are statically indeterminate. Okay, statically indeterminate. But I want to give you some brief concept on two hinges arches. At least you should know the concept that how can you solve that. After that, if you are comfortable in forming equation and solving parabola and circle, then you can solve the problem. Okay. So two hinges arches, what you are going to do, see here. The thing is, suppose this is your two hinge arch. Listen to me very, very carefully. Only concept I am going to discuss here. doesn't matter it is parabolic or circular. I'm not going into the geometries and all. Okay, and let's say it is a support A, B, C. So this 2 hinges arch is statically indeterminate of degree 1. Okay, so total 4 reactions are there and no internal discontinuity. So that is why it is indeterminate of degree 1. Okay, let's say it is RA, it is RB, it is HA, it is HB. Okay, and yes, HA and HB are same in case of no loading, and RA and RB you can calculate simply on the basis of what? Simply by considering the span to be simply supported, and by considering the load you can easily able to calculate RA and RB. So one thing which I want to tell you, in two hinges arch you can still calculate the vertical reaction. Are you agreeing to me or not? Tell me. In two hinges arch you can still calculate the vertical reaction. Tell me. Yes or no? RA and RB are not unknown to you. Yes. Is it clear? So, thing is, what you have to do, this is your arch. Okay. So, it is going to be like this. Okay. So, this you already know. This one you already know. RA you know, and RB also you will be knowing. Okay, RA and RB you will be knowing. But yes, let's say this is redundant. Let's say you do not know HB. Okay, so one thing is sure, while you are analyzing two hinges arches problem, the actual unknown is horizontal force, not the vertical force. Okay, the actual unknown is horizontal force, not the vertical force. So what I am doing here, I am again, so if my HB and HA are unknown, so in that case what we have to do, in that case what we have to do, so if this is actual unknown, so let's say I am considering this to be actual unknown HB. So I am marking it with different color. Let's say green. So this is my unknown. This is my redundant actually. So now I want to apply force method to analyze this HA. Okay. So you all know how to apply the force method. And one more thing is there. Once the value of HA is known to you, then by doing summation of fx is equal to 0, you can calculate the value of HA. And you also know RA plus RB is already known to you by just using your two equilibrium equation. Summation of fx, summation of fy is equal to 0 and summation of mz is equal to 0. Once the value of HA is known to you, then summation of fx is equal to 0, HA is also known to you. Most of the time it is similar. Is it clear to all my dear friend? But here to calculate the value of HA or of HB, the things are not that easy my dear friends, because unlike three hinges arches, we do not have any discontinuity at any internal point. Otherwise what we would have done, about the internal discontinuity, we have simply taken the moment of these forces either from right hand side or from left hand side in order to calculate the value of horizontal forces. Is it clear? But here is a problem, that how actually we have to calculate the value of HB or HA. And suppose if I have to work in terms of HB, then what we have to do? Listen to me. First of all, whenever some two hinges arches problem are given to you, okay, then what you can do, you can always uh, make a similar beam of same span. So let me tell you that This is a beam. Okay, of same span L, and same loading is acting here, and due to that same reactions are going to be generated. RB and sorry RA and RB, and you all know this area is same, and this RB is also same. Is it clear? But you can say here that here the bending moment is beam moment. Let's say bending moment of this is m naught. Then here the bending moment is beam moment minus hb into y. Tell me agreeing or not. Tell me. I am writing here that bending moment at any section is equal to beam moment at any section minus hb into y. Can I write this? Tell me, can I write this, yes or no? Please give me your confirmation on this statement. Whether I will be able to write this or not. Tell my dear friends. अरे बोलो भाई. यस लिख सकते हैं आयुष. ओके चलो ये लिख सकते हैं. ठीक है, आप लोगों की सहमति हो गई यहाँ पे. ठीक है, अब देखो आगे. I have to calculate the value of HB. I have to calculate the value of HB. Okay, that is for sure. So now how can I proceed for that? HB निकालना है, कैसे किया जाए बताओ. DS is equal to 1. Okay. Do you know one thing here? That net horizontal deflection at B is equal to 0. If somebody is asking you that what is the net horizontal deflection at B? Why only horizontal deflection? Because I am interested in HB. If I would have interested in vertical, you can say reaction, in that case I can say even the net vertical reaction at B is equal to 0. But here, yes, I have to calculate HB value, so that is why I am interested in the horizontal deflection. So as I know that net horizontal deflection at B is equal to 0, and I also know that the load responsible for horizontal deflection is nothing but HB. Okay, so this is equal to 0. Agreed? So how to calculate del U over del HB? So del U over del HB is nothing but, you can say, m square ds upon 2ei. This is u. इसको कर दो differentiate. This is going to be equal to del U over del HB, and this has to be equal to 0. Okay. So if you are solving this, then you will be getting 2m del m over del HB into ds upon 2ei is equal to 0. Okay. So this is the thing here. Okay. So now what is m and what is del m by del HB? This is my m. And if I want to know what is del m by del HB, then it is equal to minus y, isn't it? Then it is equal to minus y, because this will be equal to 0 and here HB will be eliminated, so y will be only left here. So now my dear friend, I can write here m del m over del HB into ds upon ei is equal to 0. So in place of m, I can always write beam moment minus HB into y. In place of, you can say, del m over del HB, I can write minus y. I can write minus y into ds over ei over ei. Okay, इंटीग्रेशन तो आएगा. Then this is equal to 0. So it is integration of minus m naught y ds over ei plus integration of HB y square upon EI. So HB is going to be equal to integration of m naught y ds upon EI divided by integration of okay. So this is a way to calculate the value of you can say the value of HB, and after doing this, see this m naught is the simply supported beam moment. This y you can express as a function of x. If it is a parabolic arch, then you can write y is equal to 4hx l minus x upon l square, and if it is circular arch, then you can establish the relation. Okay, so how many discontinuity will be there, so that many functions will be there, so it will be automatically get added up. Okay, so this is a way to calculate HB. So after solving this, try to break this integration into two parts. Let's say the numerator is I1 and denominator is I2, and try to solve I1 and I2 independently, and then take the ratio of I1 to I2 in order to calculate the value of HB. And my dear friend, once this HB is known to you, after that you know there is nothing left in the question. So RA, RB are known to you, HB is known to you, H is also known to you. Now you can calculate bending moment at any position. You can calculate normal thrust at any position. You can calculate radial shear at any position. So now it is completely a function of geometry. You have to simply apply geometry. So structure is over. At the moment when I did del U over del HB is equal to 0, at that time structures was over. After that we solved this, okay, and we got this expression for HB. So it doesn't matter whether it is circular arch or parabolic arch, we have to use this equation. And after that Hull Craig is asking, sir, ds is equal to dx. See, ds is in the direction of you can say distance, in the direction of propagation. So if it is like this, so what you can do here, Hull, suppose you are able to express y as a function of x, then you can write y is equal to 4hx l minus x upon l square. So in that case you can write, you already have expressed this y as a function of x, then write dx. Okay, and suppose if you want to proceed in the radial format, theta format and all, and suppose that is very much valid for circular arch. So if it is a circular arch, Hulk, then it is ds. Actually this is ds, and this angle would be d theta, and it would be r. So you can write d theta is equal to ds over r. So in that case ds would be r into d theta. So that is the mathematical demand, that how you are able to solve that. Okay, you can watch one or two problems from any book, and you will be easily able to calculate them, and you will be learn that how to place dx or ds. Is it clear, Hulk? Because one question if I am taking, then it is definitely going to take the huge time here. Okay, do you want me to take one problem on this? Tell me. If you want me to take one problem, then I can take. Okay. Okay. असाइनमेंट ये कर लो फिर, सिंपल सा है, और इसका स्टैंडर्ड रिजल्ट याद भी कर लेना, ईएससी में बड़ा काम आता है. Let's say it is a parabolic arch. Let's say ACB is parabolic two-hinge arch. Calculate HB. And this length is L. and consider here the maximum height h. So give answer in terms of w, l and h. Okay, so this maximum height is h. Okay, this is one problem. Okay, and second is, this is parabolic arch. Second is, consider a semicircular arch. Semicircular arch, you know na? This is r. Span would be 2r. Semicircular means half circle, semicircle. And this time, this is entirely loaded with a UDL. W. Okay. Now calculate the value of horizontal force. This is R, this is 2R, and this is W. So give the value of H. Is it clear? So try to solve these two questions. And yes, these questions are very, very lengthy if there is a interference of a point load. Because each and every time you are getting a point load, your bending moment function, limits, etc. will be changed. Okay. Is it clear to all? Tell me friends. कोई डाउट किसी को यहाँ तक? ओके, चलिए, जस्ट ए मिनट. ओके, चलो, नहीं होता अगर क्वेश्चन तो सॉल्व करूंगा. ठीक है, अब स्टार्ट करते हैं इन्फ्लुएंस लाइन डायग्राम. स्टार्ट करते हैं इन्फ्लुएंस लाइन डायग्राम. सो गिव द हेडिंग इन्फ्लुएंस लाइन डायग्राम. ओके, चलिए, लेट्स सी. ILD. So I hope you know the basic definition of ILD, that why you are drawing the ILD. Is it clear? Why you are drawing the ILD? Do you know this? ILD is basically the influence line diagram, and it represents the variation of a stress function when a unit concentrated load moves from one end to the another end. है ना? ILD हम लोग ड्रॉ करते हैं ये पता लगाने के लिए कि कोई भी एक पर्टिकुलर स्ट्रेस फंक्शन का वेरिएशन कैसा है ड्यू टू द मूवमेंट ऑफ ए यूनिट कंसंट्रेटेड लोड. ओके, stress function may be bending moment, it can be reaction, it can be shear, it can be even slope, or it can be even deflection. Okay, so that is the rule for draw the ILD. Okay, so due to the ILD, just by inspecting the ILD, you will be able to tell that for what position of a load that particular stress function is going to be the most critical. है ना? चलो, ये तो हो गई किताबी डेफिनेशन जो हम लोग बुक्स वगैरह में पढ़ते हैं. नाउ लेट मी ट्राई टू यू एक्सप्लेन व्हाट इज एग्जैक्टली ILD. लिसन टू मी वेरी वेरी केयरफुली. I will write the definition later on. Now see, my dear friend, suppose here I am having a beam. So my dear friend, now first time we are going to vary our load. Okay, until now what we were doing, we were only studying about the static load, and this time we are going to incorporate the movement of load. Okay, अच्छा, आयुष जी ने एक क्वेश्चन और पूछा था, टेम्परेचर इफेक्ट इन आर्च. ओके, टेम्परेचर इफेक्ट इन आर्च भी बता दूं क्या अभी? कुछ नहीं करना आयुष, प्लस करके एल अल्फा डेल्टा टी समेशन या इंटीग्रेशन करके डेनोमिनेटर वुड बी सेम। मैं क्वेश्चन ही करा दूंगा आयुष, है ना, अभी मेरे को आईएलडी कराने दो, है ना। ओनली दिस कंपोनेंट विल बी एडेड, जैसे मैंने आपको उसमें बताया था ट्रस्ट में, ओनली दैट कंपोनेंट वुड बी एडेड हियर। ओके, डोंट वरी फॉर दैट। इज इट क्लियर? ओके ओके। सो क्या बता रहा था मैं आपको आईएलडी के बारे में? ए बी, suppose there is a unit load one, and let's say this distance is x. This circle means rolling load. It can roll over AB. Okay, listen to me very carefully. It can roll over AB. So my dear friend, due to the movement of this unit load, what are the various component of forces acting at A, B and any intermediate location, etc. This we have to see here. Okay. For example, you only tell me, all of you are going to tell me. So when this load is just entering in the beam AB from left to right, so at A, what would be the reaction when this unit load will be at A? I am asking you, at A, what will be the reaction when this unit load will be at A? Tell me. ओके आयुष, मैं ले लूंगा, ठीक है, एक मैं ले ही लूंगा एक क्लास और जॉब, ठीक है। एक काम करूंगा, दिस आई विल कवर इन टेस्ट सीरीज, ठीक है। One, Harshit is saying one, okay. And when this one unit has been moved to, let's say, center, so now what is the reaction at A? Okay, let's say I'm considering 2 points simultaneously. Let's say A, reaction at B. Okay, so when the position of load was here, it was equal to 1 and it was equal to 0. When the position of load was here at the center, it was equal to 0.5 and it was also equal to 0.5. When the position of load was, you can say, here, let's say L by 4, 3L by 4, so it was 0.25 and it was 0.75. And when load was at B, at that time it is 0 and it is 1. Okay, my dear friend, this is nothing but your ILD. This all is nothing but your ILD. See, what is ILD? ILD is uh, for RA, these all are the ordinate to plot ILD. For ILD plotting for RB, these all are the ordinates. Means what you have to see while drawing ILD, that you are going to draw ILD only for a fixed location, only for a fixed stress function, but location of load is going to change. For example, by these two observations, okay, I can plot two different ILD, one for RA and another for RB. Okay, let's say two persons are assigned, one at A and another at B. So A person is seeing what is actually happening due to the movement of load, and B person is seeing what is actually happening at the movement of load. Suppose if I am drawing the variation diagram with respect to person sitting at A, then how I'll feel? See here. Suppose this is my, you can say, Yes. Let's say this is my base with the red color. Let's say with yellow color only. Okay. So if I'm drawing the ILD for RA, let's say I'm drawing ILD for RA. Okay. Then what I will feel when position of load is this, RA was equal to 1. When position of load is this, okay, RA was equal to 1. Okay. So this is the scenario there. When position of load is this, so at that time RA was equal to 0.5. Okay. Here. So the line is going almost like this. So when position of load was at A, so its value was equal to 1. When it was at the center, its value was equal to 0.5, and here its value was 0.25. So here this value is 0. So my dear friend, each and every ordinate of this ILD, each and every ordinate of this ILD is telling you the value of a stress function at A only. But why these ordinates are different? Because the location of load is changing. So RA was 1 when load was over it. RA was 0.5 when load was here. RA was 2.5 when load was here. RA was 0 when load was here. So each of these value, my dear friend, this one, you can say this one, this one, this one, this one. So all these values are representing, are telling you the value at A. The value at A. But why these values are different? Because location of the load is changing. So you can say when the location of load is here, so this is the value at A. When location of the load at is here, means at the center, so this is the value at A. When the location of load is here, then this is the value at A. When the location of the load is here, then this is the value at A. Is it clear to all my dear friend? Is it clear to all my dear friend? And yes, obviously, 2 points not going to have similar kind of stress function. For example, if this time I'm going to draw the ILD from B frame of reference, so what the person sitting on B would be observing what? He is observing maybe that when load was at A, at that time the value is 0. Okay. When load was at B, the value was equal to 1. Okay. When load was at center, the value was equal to 0.5. So like this. So this is actually the ILD for RB. So this is ILD for RB. So on this green diagram, my dear friend, on this green diagram, let me use one color here. So this is the value here. Okay, so this green one is representing the ILD for a different stress function, means the reaction at A. Okay, is it clear to all, my dear friend? And many of you might be thinking that why I am drawing it linear. So it is very much clear that from here if value is 1 and for half its when value is 0.5, then obviously it is going, and at B value is 0, then obviously this variation is going to have a constant flow. Is it clear to all, my dear friends? Okay, great. Okay, so this is actually influence line diagram for RA and RB. And one thing which I keep repeating and I want you to make you understand that each and every ordinate of ILD is representing the value of a stress function at a particular location. Once again I am repeating, if I am seeing the ILD for RA, if I am seeing this one, then all these ordinates, this one, 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 are going to represent the value of stress function at A only. And all these ordinates, this one, this one, this one, this one, this one, this one, are going to represent the value of stress function at RB. But why these values are different? Because due to the movement of load. Okay, load is moving, due to that movement these stress functions are also changing, and it is quite obvious that it influence at A when one is at A is different than one will reach at B. Now, what is influence line diagram? What do you call influence in Hindi? It is प्रभाव. किसी भी लोड के आने के कारण किसी भी सेक्शन पे क्या प्रभाव पड़ता है, that we are going to see. Okay, so that is why we are studying it in this heading. Is it clear? Is it clear to you or not? Tell me. Okay. So I want to write here that ILD, it represents the variation of a stress function like shear force, reaction, bending moment, slope, deflection when a unit concentrated load moves from one end to the other. When a unit concentrated load moves from one end to the another. Okay, so this is the definition of ILD, है ना? So why ILD is used? देखो जितना मैंने बताया इसी से आपको समझ में आ गया होगा. ILD सबसे ज्यादा यूज कहाँ होता होगा? ILD सबसे ज्यादा यूज होता होगा एनालिसिस ड्यू टू द मूवमेंट ऑफ लोड, लाइक इन ब्रिजेस, ट्रसेस, है ना, जहाँ पे लोड मूव करता है फ्लाईओवर के ऊपर, ब्रिज के ऊपर, और आप देखते हो कि किसी पर्टिकुलर लोकेशन पे क्या क्या फोर्सेस हो सकते हैं. Is it clear? Is it clear to all, my dear friend? And ILD is also helpful in calculating the position of live load which will be producing a particular value of a stress function. For example, if I am asking you that, yes, if I am asking you that when the reaction at A will be maximum, when the reaction at A will be maximum, so what you will say? When the reaction at A will be maximum? Tell me. when load is on A, and when the reaction at B is maximum, when load will be on B. So just by looking at this diagram, you have seen that the maximum value of RA is here. It means this must be the location of the load. Just by seeing this diagram, you have seen that RB is maximum here, means this is the position of the load, isn't it? So ILD is helpful in plotting, in studying the variation of a stress function due to the movement of unit load. ILD is helpful for finding the position of a live load which can produce the maximum value of a particular stress function. Okay, and apart from that, ILD is also helpful in calculating the resultant value of the stress function due to the combination of one or two more load. Okay, that I will tell you later, that how to do that. Is it clear to all my dear friends? Okay, so all these are the benefits of ILD. Okay, so don't worry my dear friends, I am going to give you a very easy technique to draw the ILD. Okay, so I'm going to give you 3 to 4 points like that, that you will be able to solve most of the objective questions in no time. Okay, that is my guarantee. So in ILD I'm going to give you 3 to 4 methods like that, so you will be able to solve them in no time. Is it clear to all my dear friends? Okay, so all these are the benefits of the ILD. Okay, so okay, let me plot some more ILD. For example, in a same B, let's say if I want to draw ILD at this position, let's say at C, then how to plot? Let's say C is a point which is located at a distance A from A, and let's say the overall length of the beam is L. So I need to know that what is going to be the shear force ILD at C, and what is going to be the bending moment ILD at C. Shear force at C and bending moment at C. Okay, let me reframe the question. Question is that it is a simply supported beam whose length is L, A and B. Let's say length of the beam is L, and this is the point C. Okay, and let's say some unit load is moving here, 1 unit load. Okay, why only 1 unit load, not 2 unit load, 3 unit load, 100 unit load? Why we are considering only a unit load? I hope all of you can answer from your common sense. In civil engineering, many times you are talking about unit load. In ILD, even although I do not have much idea of irrigation and hydrology, but I think in subject, I think either in hydrology or irrigation, you are going to draw some hydrograph. That also you say unit hydrograph. I don't know what is unit hydrograph, but Chetan sir, you keep telling unit hydrograph, hydrograph. So I cannot understand what is that, but from unit name, one thing is clear to me, that they wanted to analyze is for unit amount, because in future they can always expand it. Yes, like what we used to do in the childhood, whenever the cost of 20 chocolates were given to you and you wanted to find it for 5, then the very first task which you do, you try to calculate it for a unit amount, then you simply multiply it by 5. So similar concept is here. So if we are already drawing the stress function variation for a unit load, then in future if in place of unit 100 kilonewton, 200 kilonewton, or the set of combination loads are occurring, then we can identify them. Okay, yes, simply it is simple for multiplication for any other load. Okay, very good. Chalo. So now the question is that you have to calculate, you have to draw ILD for RA, RB, shear force at C, and Just a minute. Shear force at C and bending moment at C. Okay, so all these things you have to calculate. Is it clear? All these things you have to calculate. So tell me. So see, R and RB, although you have already calculated, but whenever we are again going to draw them for shear force and bending moment, so again RA and RB will be calculated by on. Okay, see here. Suppose if this is RA, my dear friend, today I am going to teach you only first principle. But believe me, once I will be taking tomorrow's lesson and I'm going to give you 3 to 4 tricks like you will be able to solve any question of ILD in no time. Okay, that is my promise to you. And you know, very rare I make promise for any topics. See, RA and RB. So how to calculate the reaction RA and RB? So if I'm going to do summation of Fy is equal to 0, then RA plus RB is equal to 1. This is one thing. And if I'm going to do summation of mz is equal to 0, let's say about A, then you can write minus RB into L plus 1 into X is equal to 0. So RB is X by L. If RB is X by L, in that case RA is going to be 1 minus X by L. Is it clear? Is it clear to all? So 1 minus X by L. So you can see if this is 1 minus X by L, इधर ही लिख देता हूं. So this is nothing but the function for plotting ILD only. For example, let's say if this is your reference and if you want to construct ILD for RB, then for RB the variable is how much x? So at x is equal to 0, at x is equal to 0, value is 0. At x is equal to L, value is 1. At x is equal to 0.5, L by 2, value is 0.5. So this is the variation. Similarly, if you want to draw the ILD for RA, so at x is equal to 0, value is 1. Okay. And at x is equal to L, value is 0. Tell my dear friend, is it clear to you or not? So here this is the ILD for RA and RB. So here RB and RA ILD are already drawn. And you can see the degree of this function is 1. The degree of this function is 1. That is the reason why this diagram is coming out to be linear. Okay. So on a same frame I have drawn two ILDs. One for RA and another for RB. Okay. So you can see here that it is already same. Okay. It is already same. So now the next thing is, now the very important thing, how to draw the ILD for shear force at section C. Okay, for shear force at any arbitrary section which is located at a constant distance from left support A. Okay, so see here, how to write the equations for shear force at C. So let me draw them again. Now see, RA you already calculated, it is 1 minus x by L, and it is x by L. ठीक है. So what is shear force at C, my dear friend? You only tell me what is going to be the shear force at C. Tell me. What is shear force at C? So shear force at C is equal to RB with negative sign. But this minus RB, will be there at C only and only until this A1 unit load is crossing C. Listen to me very carefully, my dear friend. I am saying shear force at C would be minus RB, but the condition is this one load, this unit load should be located on the left side of the section C, because if it is going to cross C, then along with this RB, I have to also incorporate the effect of unit load. So that is why I am saying, so shear force at C is equal to minus RB, but the location of this unit load must be beyond C. So I can say this function is valid if the value of x is less than or equal to A. If the value of x is less than A, not equal to A, because at equal to A, function can again be discontinuous. And let's say, my dear friend, suppose this unit load is now here. This is crossing C. Okay. So at that point of time, what is the value of shear force at C? So now if this one is here, somewhere here, and remove this, so and this is x, so in that case, what is the shear force function? It is minus RB. I am considering from the right hand side, it is minus RB, but it is plus 1 as well, because this unit load has crossed C. So right side downward is going to be negative, isn't it? So that is why I can write, my dear friend, that when x is greater than A, at that point of time, value of shear force is minus RB plus 1. I hope you understand why this plus 1. In short, I want to say that shear force function is going to have two values. One is minus x by L, another is minus x by L plus 1, 1 minus x by L. And this would be valid when x is less than A, and this would be valid if x is greater than A. Let me please tell me, guys, if this function making is clear to you. Tell me very frankly, if how I have created this function, whether this thing is clear to you or not. Tell me all of you, is it clear to you? Okay, so if you want to plot them, okay, okay. So how to solve it? Let's say when x is less than A, तो value कितना हो जाएगा? Minus x by L. So at x is equal to 0, value is 0. And at x is equal to just A only, so value is minus A by L. And the moment x is greater than A, so just right hand side of C, value is 1 minus A by L plus, and at x is equal to L, value is again coming out to be 0. So my dear friend, this is the scenario here. So here the function value is minus A by L, and here the function value is L minus A by L or 1 minus A by L. Okay. सर हमें सर यूनिट लोड को कंसिडर्ड पॉइंट के लेफ्ट और राइट देखना है ऐसे. Yes, exactly. You know why? Because my aim is to cover entire section. Okay, as long as this 1 unit load is dancing between A and C. So still the value of shear force on CB portion is same. It is minus RB. But what if this load is crossing C point? So for that we also have to incorporate the effect of 1. So total I have divided this case into two components. When a unit load is on AC span, and second when this unit load on CB span. Okay. If this unit load is on AC span, then I am calculating shear force from right hand side and there is no interference of a unit load. So that is why I have written minus RB from right hand side. And when this unit load is crossing C at that particular time, it is minus RB plus 1 downward. But when it will be actually crossing C, when the value of X is greater than A. And when it will be not crossing at C, since I have defined X from A, when X is less than A. So by considering these two cases, I have made the two functions of shear force diagram. Is it clear, my dear friend? Is it clear? So I can say that it is the ILD of ILD of shear force at C. Clear? Shear force at C. Okay. Okay. ठीक है. So now last, how to draw the bending moment for C. Now see. Suppose if I want to draw the bending moment here. So how can I plot the bending moment? So bending moment at C is equal to section 1 it is equal to minus RB into, let's say, X. X is already there. I have to calculate bending moment at C only, because I'm going to draw bending moment at CILD. So means each and every time, my dear friend, I have to calculate the bending moment at C. So bending moment at C is equal to RB into this distance. It is equal to RB into L minus A. So you can write here it is X by L into L minus A. Okay, but again I can say this is only valid when this unit load is located on the left hand side, because had this unit load been on the right hand side, in that case the interference of this unit load would also have been there. So in that case it would have been X by L into L minus A minus 1 into something something something, leave around. Okay, so how can I make you understand this? I am simply making this beam one more time. Let's say like this. Okay. So if this is going to be to the right hand side, let's say somewhere here. Okay. So here the x is less than a, and here the x is greater than equal to a. Means this segment is going to cover till the location of load is at AC, and this is going to cover when the location of load will be at CB. Okay. So it is 1 unit load. Okay, it is 1 unit load. So it is going to be A. It is going to be L minus A. Okay, so again this is same. It is 1 minus x over L. It is x by L. So at for this condition, I can say for this condition, bending moment at C would be RB into CB means L minus A. So it is RB into L minus A. So I can say it is x by L into L minus A, and the value of x is less than equal to A. Okay, so this one. And for this one, I can say that bending moment at C is equal to here. So I'm writing it cross. It is equal to, why to go from right hand side, because from right hand side there would be x by L as well as there would be, you can say, 1. So better to go from left hand side. So here it is 1 minus x, it is L minus x by L RA into A, that's all. So bending moment at C is equal to A into L minus x over L, and x is greater than A. X is greater than A, greater than equal to A. Okay. So in short, I can say I have formed the two functions of bending moment. So the bending moment function can again be divided into two parts. One part is this one, x by L minus A, x by L into L minus A, and it will be activated when your x would be less than equal to A, and the second function of bending moment would be A L minus x over L, A L minus x over L, and here the x would be greater than equal to A. Is it clear? So if I'm going to draw the diagram, okay, so if I'm going to draw the diagram, then okay, so when x is less, see, degree of the function here is as well 1 only, because the maximum degree of the variable is 1 only. So at x is equal to 0, value is equal to 0, and at x is equal to A, so value is L minus A over L. Again at A, value is A L minus A over L, and at x is equal to L, value is 0. So this is equal to A L minus A over L. Okay, so this is the ILD for bending moment at C. Okay, this is the ILD for bending moment, shear force at C. This is the ILD for RA and RB. Okay, so my dear friend, this is the procedure to draw the influence line diagram on a simply supported beam due to the variation of stress function. Okay, unit stress function. Okay, India में Made Easy is a brand. They have only set up to earn money, no real education. ओके आशीष, आशीष किसी के बारे में भी ये सब मत लिखो ऑनलाइन प्लेटफॉर्म में, डोंट वरी, किसी के बारे में भी ये सब मत लिखा करो, ठीक है? इधर देखो, okay, so I'm telling you this, that due to the movement of a unit concentrated load, okay, the variation of stress function RA, RB, okay, and shear force at C, and bending moment at C is going to be like this. Okay. So tomorrow I am going to give you some important points like the ILD for a determinate structure is always linear. Okay. Like the displacement of a stress function at a location of ILD is 1. Okay. Then Muller-Breslau principle. So several such points are going to give you confidence to attempt any questions in no time. Okay. So right now intentionally I am taking these methods with a first principle, with a long procedure, with the basics. Okay. Because if all these things will be known to you easily, then very easily you will be able to link up with the shortcuts which I am going to tell you. Because you should also understand that what logic I am going to give to support that shortcut. Okay, so that is the reason why I am telling you all these things in detail. Yes, obviously. Why not, Ashish? ILD of a arch of a truss is possible. Okay, but I will be covering only up to truss only. Okay, I will be covering the truss. But arch ILDs are also very easy. Just by superposition, you will be able to draw the ILD for arch. Plot it for B movement, then plot it from thrust movement, then superimpose them. जैसे हमने bending movement बनाया था ना displacement method में, like in that fashion you can draw the ILD of a arch as well. Okay, don't worry for that. Okay. So my tomorrow's topic would be uh, ILD with shortcuts and Muller-Breslau principle and good problems on ILDs. Okay, okay. After that, we will be seeing the effect of you can say rolling load on simply supported girder. Okay. Actually, that point of time, so things were I was needing full page, so I deleted my photo. Is it clear, my dear friends? Okay. So let me stop here only. And if any of my friend is interested in Unacademy Plus subscription, which is having daily live classes, crash courses, rank improvement batches, weekend test, okay, and all such facilities, courses are running on bilanguage, then you can simply download this Unacademy learning app, my dear friend, and there you can always promote this code. And consider this code to be a universal code. It is valid for GATE and ESE, but apart from that, you can able to promote this code for various other competitive fields like SSCJ, ITJ, NEET, CAT, UPSC Civil Services, Bank Services examinations, etc. Even from 6th to 12th class. So for all the courses, you will be able to apply this beautiful code S10 and avail 10% off on your Unacademy Plus purchases. Is it clear to all my dear friend? And my dear friend, this is our official Facebook channel. This is our official Telegram channel. And these are the various study channel offered by YouTube. And right now you are watching Unacademy Gate CE. And if you have not subscribed this channel, then please do subscribe just now. Thank you, my dear friend. Thanks a lot. Stay safe. Don't be stay safe. Don't go outside if it is not required.